In this video, we are required to find the area of the rectangle. So we have three identical circles, each of radius 1, that are tangent to each other. As you can see, this circle is tangent to this circle at this point. This is tangent to this circle at this point. This is tangent to this circle at this point. So they are tangent to each other and they are identical. So they all have radius of 1. And they are also tangent to the rectangle. So you can see that this circle is tangent to the rectangle at this point and at this point. This one is tangent to the rectangle at this point and at this point, while this one is tangent to the rectangle at this point. So with that information, find the area of the rectangle. So for us to find the area of the rectangle, of course, we are going to find the length and width, because area of a rectangle is given by length times width. So we need to determine this side length and also this side length. Okay? So let's start by labeling the points on our diagram. Let this be M, N, P, and this one Q. And let the centers of the circles, let this one be center R, this one S, and this one T. Next, let's connect center R to center S. Just like that. As you can see, we come up with a straight line or a long straight line that combines two diameters. So it combines the diameter of this circle and the diameter of this circle. Now, since the radius of each of the circle is 1, so from here to point R is 1, from R to this point is 1, from here to here is 1, and also from here to here is 1. That implies that when we combine all of them to make one line, we shall have this line being equals to this line. Since it's a straight line, it is equals to MQ. So MQ will be equals to 1 plus 1 plus 1 plus 1, which is equals to 4. So 4 is the combination of two diameters. Okay, so next let us connect center S to center T. So I'm connecting center S to center T. Next, let us draw a line, a perpendicular line from center T to line RS, and all the way, it continues all the way up to this line MQ. So let me draw a perpendicular line from point T just like that. As you can see, this line passes through the point of tangency of these two circles. Okay. Now let me call this point here, let me call it V. Now, as you can see, we have this line is a line of tangency to these two circles. And this line from here to here is radius, and also from here to here is radius. So we know that from tangent to a circle theorem, and the angle between the radius and tangent line is always 90 degrees. So this is the tangent line. So definitely this will be 90 degrees. This is also 90 degrees. So this is also 90 degrees. This is 90 degrees as well. So remember, we got our MQ as 4. So now remember, we've said this is point V. Now focusing on triangle TVS, we know that VS is radius of the circle. So VS is 1. Then we know that from S to this point is radius, which is also 1. and from here to here is also radius of this circle, which is 1. Therefore, TS will be 2. Since the triangle TVS is a right angled triangle, we are going to solve using Pythagoras theorem, which is a squared plus b squared is equals to c squared. Our a is Vs, so Vs squared plus our b is Vt, so Vt squared is equals to our c, the hypotenuse, is St, so St squared. So Vs is radius 1, so 1 squared plus Vt, we don't know, so Vt squared is equals to St, we got it as 2, so 2 squared. So we make Vt the subject, so Vt squared is equals to 2 squared minus 1 squared, and so Vt squared is equals to 2 squared is 4, 1 squared is 1. Vt squared will be equals to 4 minus 1 is 3. Want to get rid of this square, so we find the square root on both sides. This cancels, and so Vt is equals to square root of 3. Therefore, Vt here is root 3. Now, as you can see, from here to here, if we are to draw an imaginary line here, this would be radius. And also, this line would be equals to this line. That implies that this line is radius, so it's also equals to from here. So from this point to this point is equals to radius, which is 1. Then from here to this point is equals to Vt, which we've got as root 3. So this is root 3. Then from here to here is the same as radius from this point T to this point, which is 1. So this is 1. So now side QP is equals to 1 plus root 3 plus 1, which is equals to 2 plus root 3. Since they wanted us to find the area of the rectangle, so we have been able to find our length, which is MQ, which is 4, and our width, which is QP, which we've got as 2 plus root 3. So now we can find the area of the rectangle. Now we know that area is equals to length times width. So area, our length is 4, and our width is 2 plus root 3. So area is equals to 4 times 2 is 8, plus 4 times root 3 is 4 root 3. So area is equals to 8 plus this gives us 6.9282. And so area, when you add this, is approximately equals to 14.93. This is in square units. So this is square units. This is the area of the rectangle MQPN. Thank you so much for watching. Kindly subscribe to this channel for more amazing videos. Like, comment, and share your thoughts about this video in the comment section down below. If you have alternative approaches as well, you can share them with us. Those who haven't subscribed, please subscribe. It's completely free of charge. Thank you so much. Let's meet in the next video.